Imagine the beginning of modern artificial intelligence language models. Before today's advanced chatbots, there was a first breakthrough. That breakthrough was called GPT-1 by OpenAI researchers. GPT stands for Generative Pre-trained Transformer Technology System. It marked the start of large language model evolution. Released in 2018, it changed how machines understand text. GPT-1 used deep learning to process natural language data. It was trained on a massive collection of internet text. The model learned patterns from sentences and word relationships. Instead of rules, it relied on statistical language learning. This was a major shift from traditional AI systems. Traditional systems required manual programming for every task. GPT-1 learned language automatically through training on data. It used transformer architecture to understand word context. Transformers helped it process sentences more efficiently than before. Each word influenced meaning of surrounding words in sentence. This attention mechanism improved understanding of language structure greatly. GPT-1 had around 117 million parameters total. Parameters are like memory units storing learned language patterns. Compared to modern models, it was a relatively small system, but it demonstrated powerful capabilities for its time period. It could generate coherent sentences from simple input prompts. It also performed tasks like translation and summarization basics. GPT-1 showed that pre-training improves language understanding significantly. Pre-training means learning from large data before tasks. After pre-training, it was fine-tuned for specific tasks. Fine-tuning improved performance in targeted applications and domains. This two-step process became standard in later models. GPT-1 used unsupervised learning during its initial training phase. It predicted next words and sentences repeatedly during training. This simple objective produced surprisingly intelligent language behavior patterns. The model learned grammar, facts, and reasoning indirectly from data. However, it still struggled with complex reasoning tasks often. Long conversations were difficult for GPT-1 to maintain coherence. It sometimes generated repetitive or nonsensical outputs during usage. Despite limitations, it proved concept of large language models. Researchers realized scaling models improves performance dramatically over time. GPT-1 inspired development of GPT-2 and GPT-3 later. Each new version became larger and more capable system. GPT-1 architecture was based on transformer encoder-decoder design. It used self-attention to process word dependencies effectively. Self-attention allows model to focus relevant words contextually. This mechanism replaced older recurrent neural network approaches completely. Training required large computational resources even at that time. GPUs were used to accelerate model training processes efficiently. Dataset included books, articles, and diverse web text sources. This diversity helped model understand multiple language patterns better. GPT-1 was primarily research-focused rather than commercial product. Its goal was to test language model pre-training concept. Results showed significant improvement over previous benchmark systems clearly. It outperformed many traditional models in language tasks evaluation. However, it was not yet capable of human-like conversation. The model lacked deep understanding of real-world reasoning. Still, it laid foundation for conversational AI revolution today. GPT-1 demonstrated that scale matters in artificial intelligence performance. Bigger datasets and models produce better language understanding systems. This insight changed the entire direction of AI research field. Many companies started investing in transformer-based architectures afterward. GPT-1 became a stepping stone for modern AI assistants globally. It showed potential of predictive text generation at scale. Developers began exploring applications in chatbots and writing tools. Its success encouraged rapid advancement in machine learning research. GPT-1 remains a historically important milestone in AI development timeline. It proved neural networks can learn language without supervision. This discovery opened door for generative AI revolution later. Today's systems build directly on ideas introduced in GPT-1. Its influence continues shaping AI research and applications globally. Understanding GPT-1 helps explain evolution of modern chat systems. It represents origin point of transformer-based language models. From this foundation, intelligent systems rapidly evolved over years. Each improvement built upon lessons learned from GPT-1. It was simple yet revolutionary in artificial intelligence history. Without it, modern AI assistants might not exist today. GPT-1 started the journey toward human-like AI communication, and this is how the first GPT model changed everything. Now, let's explore how GPT-1 actually learned language patterns. The training process is where its intelligence begins forming. GPT-1 learned by predicting next word in sentences. This simple task created surprisingly complex language understanding abilities. Each prediction helped refine internal neural network connections gradually. Over time, it improved accuracy across massive text datasets. The model was trained using transformer neural architecture design. Transformers process entire sentences instead of reading words sequentially. This allowed GPT-1 to understand context much more effectively. Older models struggled with long-range word dependencies heavily. GPT-1 solved this using self-attention mechanisms internally. Self-attention lets model focus on important words dynamically. Words in a sentence influence each other through attention. This creates deeper understanding of meaning and context structure. GPT-1 was trained on Books Corpus dataset from internet sources. Books Corpus contains thousands of fiction books and narratives texts. This helped model learn storytelling patterns and grammar structure. Training also included Wikipedia-style structured informational content sources. Diverse data improved generalization across different language tasks greatly. However, dataset quality still limited reasoning ability in model. GPT-1 did not truly understand meaning like humans do. It recognized patterns rather than forming real comprehension concepts. Despite this limitation, it still generated coherent sentences often. The model used 12 transformer layers in architecture design. Each layer processed information at increasing abstraction levels internally. Early layers handled simple word relationships and syntax rules. Deeper layers captured semantic meaning and contextual understanding better. GPT-1 contained around 117 million trainable parameters total system. These parameters adjusted during training to minimize prediction errors. More parameters generally improved performance in language tasks significantly, but GPT-1 was small compared to later AI models. GPT-2 and GPT-3 expanded this idea massively later. GPT-1 proved scaling laws work in neural networks effectively. Researchers discovered bigger models perform better consistently across tasks. This insight became foundation of modern AI development strategy. GPT-1 training required large GPU clusters for computation power. Training took significant time and computational resources overall process. Optimization techniques like gradient descent improved learning efficiency greatly. The model adjusted weights based on prediction error feedback. Each iteration made GPT-1 slightly better at language tasks. Eventually, it reached stable performance after extensive training cycles. GPT-1 was not fine-tuned for conversation initially designed. Instead, it was adapted for downstream tasks later development. Fine-tuning improved performance in classification and translation tasks. This flexibility made GPT-1 useful for multiple applications research. It demonstrated transfer learning capability in language models clearly. Transfer learning means knowledge from one task applies others. GPT-1 could adapt learned language patterns to new problems. This was revolutionary for machine learning at that time. It reduced need for training separate models for tasks. GPT-1 still struggled with long context understanding limitations present. It often forgot earlier parts of long text sequences. This limited its ability to hold extended conversations naturally. Researchers later improved this significantly in newer GPT versions. GPT-1 outputs sometimes contained repetition and logical inconsistencies errors, but overall structure remained surprisingly fluent and readable most times. This showed neural networks can mimic human language patterns. Even without true understanding, they produce useful text outputs. GPT-1 marked shift from rule-based to data-driven AI. It replaced manual programming with statistical learning approaches entirely. This transformation changed entire field of natural language processing. Companies began investing heavily in transformer-based AI systems. GPT-1 inspired wave of innovation across AI research community. It demonstrated feasibility of large-scale language pre-training approach. Pre-training became standard method in modern AI development pipelines. Today, almost all language models use similar foundation idea. GPT-1 remains proof of concept for generative language systems. It opened door for conversational AI technologies we use. Without it, AI progress would have been much slower. Its influence continues shaping modern intelligent systems development globally. GPT, the 1st of May, seems small, but its impact is massive. It represents first step toward human-like machine communication. Every modern chatbot traces its roots back to this model. It changed how we think about language and machines. And that is how GPT-1 learned to understand language. Now we explore limitations that define GPT-1 capabilities clearly. Despite success, GPT-1 had many noticeable weaknesses in practice. It struggled to remember earlier parts of long texts. This made extended conversations difficult and often inconsistent results. GPT-1 often lost track of topic during long passages. This caused repetitive or unrelated responses in some cases. Another limitation was weak reasoning beyond learned patterns. It could not perform true logical problem-solving reliably. Instead, it relied heavily on statistical word associations learned. This made it impressive but not truly intelligent system. GPT-1 also lacked real-world knowledge understanding depth. It had no awareness of facts beyond training data. This led to occasional incorrect or hallucinated information outputs. Researchers realized scaling alone would not solve all problems. Architectural improvements were also necessary for better performance systems. GPT-1 still provided strong baseline for language modeling research. It helped scientists identify key areas needing improvement clearly. Attention mechanisms were powerful, but still had constraints. These constraints affected coherence over long text generation tasks. GPT-1's outputs sometimes drifted into irrelevant topic areas. However, short-form text generation worked relatively well overall. Summarization tasks showed reasonable performance for early model stage. Translation tasks also demonstrated basic multilingual understanding capability. But results were far from human-level accuracy standards. GPT-1 also required significant computational resources during training phase. Even small compared to today's models, it was expensive. Training involved multiple GPUs running for extended periods of time. Optimization required careful tuning of learning parameters constantly. Researchers experimented with different architectures to improve efficiency further. These experiments shaped development of GPT-2 architecture later. GPT-1 showed that unsupervised learning could be highly effective. This removed need for manually labeled datasets in many tasks. It opened path for scalable AI development globally quickly. Another important insight was transfer learning effectiveness in NLP. Pre-trained models could adapt to multiple downstream tasks easily. This made AI development more flexible and efficient overall. GPT-1's success encouraged adoption of transformer models industry-wide. Many companies began shifting away from older RNN systems. Transformers quickly became standard architecture in language processing field. GPT-1 also highlighted importance of dataset diversity in training. Broader datasets improved generalization across different language tasks significantly. However, noisy data sometimes reduced output quality slightly overall. Data filtering techniques became more important in later models. GPT-1's relatively small size limited its expressive capabilities overall. Only 117 million parameters constrained learning capacity significantly compared. Later models increased parameters by orders of magnitude dramatically. This scaling improved fluency and reasoning ability greatly later. GPT-1 still demonstrated surprisingly fluent text generation for era. Many outputs were grammatically correct and contextually relevant sentences. This was considered breakthrough achievement in machine learning history. Researchers began envisioning conversational AI systems based on this. Early chatbots were very limited compared to GPT-1 capabilities. GPT-1 moved field closer to human-like text generation. It showed that language could be learned statistically at scale. This challenged previous assumptions about rule-based language systems. GPT-1 replaced manual linguistic rules with learned neural patterns. This shift transformed entire natural language processing research direction. It laid groundwork for modern AI assistants and chatbots. Without GPT-1, later advancements would not have been possible. It served as experimental proof of transformer architecture success. Researchers gained confidence in scaling neural networks further rapidly. GPT-1's limitations directly inspired improvements in GPT-2 design. Each weakness became target for next-generation model upgrades. This iterative improvement cycle drove AI progress forward quickly. GPT-1 remains historically important, despite being technologically outdated now. Its influence is still visible in modern AI systems. It represents starting point of transformer-based language revolution. Many breakthroughs today trace back to its original design. GPT-1 changed expectations about what AI could achieve realistically. It bridged gap between research theory and practical application. Its legacy continues shaping artificial intelligence development worldwide today. Understanding it helps explain evolution of modern language models. And this concludes deeper look into GPT-1 limitations and impact. Now we compare GPT-1 with modern advanced AI systems. The difference between them is massive in every aspect. GPT-1 was only beginning of transformer-based language intelligence. Modern models contain billions or trillions of parameters today. GPT-1 had only 117 million parameters total. This difference explains performance gap between old and new. Scaling up parameters dramatically improves language understanding capabilities overall. Bigger models learn more complex patterns from data efficiently. GPT-1 struggled with long conversations and deep reasoning tasks. Modern models handle multi-step reasoning much more effectively. Context length has increased significantly in newer AI systems. This allows better memory across long conversations and documents. GPT-1 often forgot earlier context in long text generation. Modern systems maintain coherence across thousands of tokens easily. GPT-1 lacked alignment techniques used in current AI training. Today's models use reinforcement learning from human feedback systems. This improves helpfulness, safety, and response accuracy significantly overall. GPT-1 was mostly focused on research experimentation and testing. It was not designed for public conversational usage applications. Modern AI systems are optimized for real-world interaction. GPT-1 required task-specific fine-tuning for different applications. Today's models are more general-purpose and flexible systems. Transfer learning has become much more powerful over time. GPT-1 introduced foundation, but lacked refinement of later versions. Attention mechanisms in GPT-1 were simpler compared to now. Modern transformers include optimizations for efficiency and scaling improvements. Training data size has increased dramatically in newer models. GPT-1 used relatively limited dataset compared to today's standards. Data diversity now includes billions of web documents globally. This improves accuracy and general knowledge significantly across domains. GPT-1 outputs were often repetitive or slightly inconsistent sometimes. Modern models produce more coherent and structured responses reliably. Error handling has improved dramatically in recent AI systems. Hallucination issues still exist, but are better controlled today. GPT-1 could not follow complex instructions properly in most cases. Instruction tuning in modern models solve this limitation effectively. This allows users to interact more naturally with AI systems. GPT-1 lacked conversational memory across sessions or contexts. Modern AI systems can maintain conversation continuity better overall. Safety systems were not present in GPT-1 architecture design. Today, models include alignment layers for responsible AI usage. GPT-1 was a research prototype rather than production system. Modern AI is deployed widely across industries and applications. GPT-1 demonstrated feasibility of transformer-based language modeling approach. It proved that pre-training large models improves performance significantly. This idea became foundation of entire modern AI industry. Companies now invest heavily in large-scale model training. GPT-1 inspired rapid innovation in neural network architectures globally. Researchers built GPT-2, GPT-3, and beyond from its ideas. Each generation improved scale, reasoning, and contextual understanding ability. GPT-1 also influenced development of open-source language models. Many academic projects are based on transformer principles introduced. Its architecture remains an important milestone in AI research history. Even simplified, GPT-1 showed surprising fluency in language tasks. This changed perception of machine-generated text quality forever. GPT-1 made AI language generation a serious research field. Before it, language models were far less capable systems. It bridged gap between theoretical AI and practical tools. Modern assistants owe their existence to early GPT experiments. GPT-1 proved scaling laws matter in neural network design. Bigger models consistently perform better across many benchmarks tested. This discovery reshaped direction of artificial intelligence research globally. GPT-1's legacy continues influencing model design choices today. Its architecture is still used in improved modern forms. The transformer remains core backbone of almost all LLMs. Without GPT-1, evolution of AI would have slowed significantly. It started chain reaction leading to today's AI revolution. Understanding GPT-1 helps appreciate progress in machine intelligence field. It represents first real step toward human-like AI. From simple predictions came powerful conversational systems over time. Its limitations guided improvements in next-generation architectures strongly. Each flaw became opportunity for advancement in research direction. GPT-1 remains symbol of innovation in artificial intelligence history. It shows how small beginnings lead to massive breakthroughs. And this comparison completes understanding of GPT-1 evolution journey. Now we reach the final stage of understanding the GPT-1 journey. This model changed artificial intelligence forever in history. It started a revolution that still continues growing today. GPT-1 proved machines can learn human language patterns. That discovery transformed the entire field of natural language processing. Before GPT-1 language models were limited and rigid systems. After GPT-1 research shifted toward large-scale transformers, this shift created the foundation for modern AI assistants. GPT-1 was not perfect, but it was groundbreaking. Its simplicity made it powerful in unexpected ways. Researchers realized scaling data improves intelligence dramatically over time. This insight became a core principle of modern AI design. GPT-1 showed pre-training is key to language understanding. Pre-training allows models to learn from massive text data. Then models are fine-tuned for specific tasks later. This two-stage process is still used widely today. GPT-1 also introduced the importance of the self-attention mechanism. Self-attention allows models to understand word relationships deeply. This helped machines process language more naturally than before. GPT-1 laid the groundwork for conversational AI systems globally. Chatbots today are direct descendants of this early model. Every improvement in AI builds upon the GPT-1 foundation. From GPT-1 came GPT-2 and GPT-3 evolution. Each version became larger, smarter, and more capable. Modern AI now handles complex reasoning and creativity tasks. These abilities trace back to GPT-1 original architecture design. GPT-1 also influenced industries beyond just research laboratories. Businesses started exploring AI-powered writing and automation tools. Education, healthcare, and technology adopted language models widely. This created a new era of digital intelligence applications globally. GPT-1 demonstrated the power of neural networks at scale. It changed perception of what AI could achieve practically. Researchers gained confidence to build larger and better systems. That confidence led to exponential growth in model size. GPT-1 was the first step in that exponential journey. Without it, modern AI progress would not exist. It served as a blueprint for future transformer-based models. Its architecture remains relevant even in today's systems. Many modern improvements still rely on the same core idea. Transformer design became the backbone of almost all language models. GPT-1 showed language understanding can emerge from data, not from rules, but from patterns learned automatically. This was a major shift in artificial intelligence philosophy. Machines no longer needed explicit programming for language tasks. Instead, they learned behavior through exposure to massive data sets. GPT-1 proved this concept works effectively in real systems. Even with limitations, it delivered surprising intelligent outputs. That surprise motivated rapid development in the AI community. Researchers worldwide began building upon its success quickly. OpenAI continued scaling models into more powerful versions. GPT-1 became the starting point of a global AI revolution. Today's AI tools all trace lineage back to it. Its influence can be seen in every chatbot system. It changed how humans interact with machines permanently. Communication between humans and AI became more natural. GPT-1 opened the door to conversational intelligence systems everywhere. It marked the beginning of machines understanding human language deeply. From simple predictions emerged complex reasoning capabilities over time. This evolution continues shaping the future of artificial intelligence. GPT-1 remains an important milestone in technology history books. It symbolizes innovation, curiosity, and scientific experimentation combined. Its impact extends far beyond the original research purpose. It created the foundation for intelligent digital assistants globally. These assistants now help millions of users daily. GPT-1 is proof that small ideas can change the world. Big breakthroughs often start from simple experimental models. It teaches the importance of research and continuous improvement. Every limitation led to better future AI systems. Progress in AI is built step by step. GPT-1 represents the first solid step in that journey. Its legacy continues shaping future innovations in AI. Understanding it helps appreciate modern technology evolution deeply. It connects past research with future possibilities ahead. GPT-1 will always remain the origin of language AI, and this concludes the full journey of GPT-1.